start off with some basic stuff. For you, those of you who are more advanced, forgive me, but not everybody knows a lot about this kind of stuff. And today we're going to talk about sound. I'm going to just give you a diagram of how sound works, microphones, amplification, and speakers. And let me move the meter because it's creating a little bit of a shadow. Okay, so sound needs a medium to travel through. Air is the best, and basically sound is moving air. And sound is a sine wave, which looks like this, right, with the center going through here. So the more of these waves per second, the higher the sound. The larger the wave, the louder the sound. So let's say you have a sound that's 20 hertz, which is 20 times per second. What would happen is that you'd have 20 of these sine waves in 1 second. It could be very, very soft, or it could be very, very loud. So what you would have is, let's say for example, a microphone. A microphone is a diaphragm, and it's connected to a coil. So you have this coil, and in the center of the coil is a magnet. So what essentially will happen is the sound touches the diaphragm, it moves it back and forth, which moves the coil, and that creates an output. It creates an electrical output from the electromagnetic field. So if it's 20 hertz, that means this diaphragm moves 20 times per second, the coil moves 20 times per second, and it creates a signal that's 20 times per second. That's a 20 hertz signal. And so you have this 20 hertz signal, and it will go to eventually a speaker. Let's say it's a PA system. Well, guess what? A speaker is a coil connected to a cone with a magnet and your input. So again, the 20 times per second will pull the coil and produce a 20 times per second 20 hertz sound coming out, because the cone will move 20 times per second. 20 times per second is very, very low. 20 kilohertz is apparently the highest humans can hear, but I don't think very many people can actually hear that high. I think the average is about 14, maybe 15. To give you an example, a drum cymbal, that's about 12 kilohertz, 12,000 times per second, and a bass drum is about 60 hertz, 50 hertz, someplace around there. So for this we're going to use 20. So 20 in, moves the diaphragm, moves the coil, signal goes along the wire, gets the speaker coil, moves the speaker coil 20 times per second, and out comes the exact same sound. However, the coil inside a microphone is very, very small. It doesn't produce very much signal, not enough to drive a speaker. A speaker has a big coil, big magnet, needs a lot of power to be driven. So you need an amplifier. So what do? You put an audio amplifier in there. Now, an amplifier is basically a small signal controlling a big signal, and that can be done by a single transistor. Now, there are different types of transistors. This one, it's just a transistor. We're not going to go into different types of transistors right now. But what you have is you have a base, an emitter, and a collector. This is where the big signal comes in through the emitter and comes out through the collector. The base is a gate that controls it. So let's now connect our microphone to our amplifier and our speaker to our amplifier. Now you have the 20 times per second going into the transistor, the gate opens and closes 20 times per second, which controls the output 20 times per second going to the speaker 20 times per second. Essentially, you would need more than one transistor, a proper audio amplifier. We're doing this for simplicity purposes. Now, the more input there is into the transistor and the base of the transistor, the wider the gate will open. It can still move 20 times per second, but it will open wider, meaning that it will allow more of the output to go through. That's called volume, what's more commonly called as volume, or as we call it more professional industry, gain. And the gain control is usually on the input, because your output could be 100 watts, 200 watts, 300 watts. You would need a variable resistor that's that size. 200 watts, 300 watts, 400 watt variable resistor, that would be huge. I don't think you could actually lift that would be very heavy. So we control this side. It's a much smaller voltage, and by controlling this, you can still control this. Turning this down to 0 means there's no control going to the base. If nothing going to the base, this is not going to be allowed through. The gate will stay closed. You put this up to maximum, the gate moves at its maximum at whatever frequency being sent to it, in this case 20 times per second. 20 times per second, but wider open each time. Turn this down, smaller control here. Gate still 20 times per second, but not open as much. So there's less going to the speaker. That's basically how your audio works. Now, sending audio from the microphone to the amplifier, there's two different ways of doing it. There is what's called unbalanced, which is 2 wires, which is commonly used consumer equipment. And basically one wire is the signal and one is ground. So signal goes, comes back, goes to the ground. The problem with this, because you have the ground is actually part of the signal wire, it picks up a lot of interference. So long stretches of cable, you'll pick up everything. You can pick up interference from fans, anything electrical. Even you might even be able to pick up a radio station. Who knows? So the professionals have done something a little bit different. They use a 3-wire system inside the cable. It's 3 pins. It's called XLR. With this system, you have a separate ground. So what happens is that both of the outputs from the coil of the microphone are connected instead of just one, and you have a separate ground cable. So what happens here is that because the ground is separate, it reduces interference to almost nothing. And this is great for long runs of cable. Everywhere I've worked, every TV station, every radio station, every professional application of audio has used this type. XLR cable looks like this. Or XLR connector looks like this. You have pins 1 and 2. Those carry the signal. Pin 3 is ground. In our application here, my microphone setup that I have here, which I'll show you in another episode, it's a balanced output, which is this kind of output. Most good microphones use that kind of output. So there you go. That is basically how sound works. This is to get you going on this. Like I said, I apologize to the people who know a little bit more, but I wanted to start off basic so everyone can understand.